Hello, this is Dr. Grande. Welcome to my video on identifying multivariate outliers using Mahalanobis distance. So I have here fictitious data in the data view of SPSS. I have an ID variable, an independent variable at 3 levels, and then 3 other independent variables measured at the scale level of measurement, and then an outcome variable measured at the scale level of measurement. And I want to test for multivariate outliers for these 3 independent variables: functioning, severity index, and motivation. So what I'm really looking for are unusual combinations of these 3 scores. Ones that would be so unusual that I would record them as outliers. And then, based on the criteria for the study, I may find some way to adjust or transform the variables based on the outliers or eliminate the outliers. So first we'll need to compute the Mahalanobis distance for all 3 of these variables. And the way we'll do that is through analyze regression. Even though a linear regression is not of interest to us, it's how we compute the Mahalanobis distance. So the dependent variable doesn't matter, doesn't affect the creation of this new variable. So we'll just use outcome as our dependent. But our independents, of course, will be all the independent variables that we want to screen for multivariate outliers. So we'll move functioning, severity, and motivation over to the independent list box. The method will remain as enter. Statistics will remain the same. Plots remain the same. Save, however, you can see under distances we have Mahalanobis. Want to check that. Continue. There'll be no changes to options and no changes to style. So I'm going to click OK, and you'll see it generates this new variable MAH1. This is the Mahalanobis distance for these 3 independent variables. And now let's sort the data set by this new variable, and we'll sort descending. And we can see there's some relatively large values compared to the more common values found in this variable. So we would suspect that there are some outliers, but we don't know for sure yet. We want to compare these Mahalanobis or MD values to a chi-square distribution, the same degrees of freedom. And the degrees of freedom in this case will be equal to the number of predictors. So it'll be 3. So go to transform and compute, and let's set a new target variable. So we'll call this one probability underscore MD. And we'll start off the numeric expression by 1 minus, and then we'll go over and we want the cumulative distribution function for chi-square. So this returns the cumulative probability that the value is from the chi-square distribution. So we'll double click that. And we want to move over the new MD variable into the first parameter. Make that the first parameter. And then for the second argument, we need the degrees of freedom, and we know that's 3. So it's 1 minus this function. So this will calculate the p-value for the right tail of this variable. So let's take a look at that. Now this only shows us 2 digits to the right of the decimal place. So I'm going to go to the variable view, and you can see decimals and probability MD. I'm going to change that to 5. So go back to the data view, and now we want to compare these probabilities against 0.001. So if one of these probabilities is below 0.001, we would consider this record to be an outlier. So the combination of these three variables would represent an outlier in that case. And you can see with the first value, 0.00015, that would be an outlier. Similarly, so would 0.00034, but not 0.004. So in this particular case, the only two outliers are ID 1007 and ID 1018. Now I want to show you an alternate way to calculate this probability. Go to compute variable, you can see it retains the last method I used. If you don't want to use the 1 minus the cumulative distribution function of chi-square, you can actually delete all this and type in sig.chisq and then the same arguments there, and hit, well, I'll change this to probably MD1 just to distinguish it from the other variable. You see it returns the same results when I go to variable view and display 5 digits to the right of the decimal. The values are equal. So either way is fine to calculate that probability. And if you're dealing with a particularly large data set and you'd like some way to flag it with a 1 or a 0, I'm just going to clear the second probability because it's the same as the first. We go into compute, and I'm going to change this label to outlier, and the numeric expression, I'll delete the old one in there and simply add in probability MD is less than, and then 0.001, and hit OK. It's going to create a new variable named outlier, and you can see the two probabilities that we identified as outliers are labeled now with a 1 in the outlier variable, and the remaining variables with a 0. So in this case, we do not want any digits to the right of the decimal place, so go to variable view and adjust this to 0. And then back to data view.